Hello students, and welcome to the final calculus lesson of the year. In this video, we're going to learn how to find volume of solids that aren't getting rotated around an axis. So let's get started. So in some cases, you're going to start to find that we're going to know the shapes, that they're not going to be circles, they're not going to be donuts, they're not going to be, discs that we're going to be looking at. So you're going to have shapes that are going to be different than that, and you're going to know what those shapes are. So for example, let's look at this first one. We know that the cross sections are going to be squares. So we know that everything that's rising out of this shape in this solid dimension is going to be a square right there, okay? And so since we can see that we have f of x right here and this is going to be g of x, we can see here that those are going to be, we could find the height or the length of that side, and then we could figure out from there what to deal with that square. So if you lay it down flat, of course we've got f of x minus g of x, that's this part right here. And then since it's a square, everything has to be in terms of that bottom side. Since it's a square, you're just gonna multiply it by itself. Since we're multiplying it by itself, we know we could find area, right? Because that's gonna be f of x minus g of x times itself, f of x minus g of x. Well, we can simplify this, of course, to say f of x minus g of x all squared. Now, think about position, velocity, acceleration. It's going to follow the exact same strategies when you're looking at area, volume, and length. And since we're going from area to volume, you know that that's going to be an integral. So in this case, we can find the volume here by going from A to B of whatever those intersection points are when we're talking about this graph, A right here, B right there. And from here, what we can do is we could add up all those tiny cross sections from A to B. And we know the area of all those shapes is just f of x minus g of x squared dx. And that's pretty much going to be the method that we're going to use no matter what the shape is. So let's go ahead and begin looking at those other shapes. In this case, we're looking at isosceles right triangles. So something that is like that shape right here. What we want to do first is find the area of this triangle in terms of f of x and g of x. Well, we know that the area is going to be 1/2 the height, 1/2 the base, which is f of x minus g of x, times the height, which is f of x minus g of x. Okay, we can simplify this. Well, that's going to be 1/2 f of x minus g of x squared. Well, looking at this again, how can we write this as an integral going from area to volume? Well, we know volume is going to be the integral from A to B of the area that we just found. So 1/2 f of x minus g of x, or of course the upper minus the lower function. We could simplify this sometimes by just taking that 1/2 out, because that is a constant multiple, and then we still have f of x minus g of x squared dx inside of the integral. All right, so now we're going to look at another triangle. In this kind, we're going to look at equilateral triangles. Again, we can figure out what the length of that base is because we have our upper function f of x and our lower function g of x. And in case of this picture, we're looking at a base where it is the x-axis. So of course, this is what we look at. If we get down, we're looking at a straight side view, we see this equilateral triangle. What I'm gonna do here is I'm gonna say, okay, this is B right now. And because I want to figure out, all right, we're gonna kind of need the base times the height, right? From geometry, you know that we have 1/2 the base times the height. Well, we don't want this in terms of two variables. We want this in one variable. And so we're gonna ask ourselves, okay, what can we figure this out with? Well, since we know that this is an equilateral triangle, we know what that angle over there is. Well, since we know that this is 60 degrees, in that since I went straight down, that bottom part is gonna be 90 degrees. And then this is of course gonna be 30 degrees because we just cut that angle in half. Okay, so since I know that this is the base, you're gonna have to remember, all right, what are the special rules for your 30, 60, 90 triangles? Well, since I just took that base and I cut it in half, so really this is just b over 2. And we have our 30, 60, 90 triangles. Well, since this is b over 2, or kind of let me write this as what you would know it from in terms of like geometry, something like that this is n, that this is going to be 2n, and that this one is going to be square root of 3 n, or n square root of 3. So now let me look at this. Well, since we know our base just got divided by 2, so then this is, again, I'm going to bring it back, b over 2. Well, since n is b over 2, well then our height is going to be square root of 3 times b over 2. Or you could rewrite that as square root of 3 over 2b, or b square root of 3 over 2. They're all the same. And so we know what b is going to be. We know b is f of x minus g of x. So then let's go ahead. We know what the height is. We know that the height now is square root of 3 over 2 times b. So if I can rewrite this as 1/2 times b times the square root of 3 over 2 times b, because height has become square root of 3 over 2 times b. So let's see if we can simplify all of this. Well, I can. That's going to be square root of 3 over 4 times b squared. So let's kind of write out what this is in terms of f of x and g of x. Well, since I know that b was f of x minus g of x, that we're going to say our area for this triangle is going to be the square root of 3 over 4 times f of x minus g of x, the upper minus the lower function, squared. So now let's say, okay, how do we find volume here? Well, we know how we can find volume. Again, that's just going to be volume of the area, and that's going to be from A to B. And this square root of 3 over 4, I'm just going to take it out immediately. So square root of 3 over 4. And then inside of the integral, we have f of x minus g of x, and that all gets squared dx. So that's how we can find it in terms of an equilateral triangle. So you do kind of need to remember, like, okay, how are all these things related in terms of a 30, 60, 90 triangle? So looking at these semicircles, we know that a full circle for area is going to be pi r squared. So since I have a semicircle, well, that's going to be 1/2 pi r squared, semi. Well, how do we figure out what this r is? Well, what I have right here, f of x minus g of x at the base of that semicircle, is going to be diameter. So if I want the radius, I want 1/2 of this. So the radius is going to be equal to 1/2 f of x minus g of x. So let's kind of put this all together right now. So we know that the area is going to be 1/2 pi times my radius, which is 1/2 f of x minus g of x. All of that ends up getting squared. So let's simplify this a little bit. Well, a equals 1/2 pi, and I can square these two terms right here. So then 1/2 squared is going to be 1/4 times f of x minus g of x squared. Just trying to simplify everything. And I can take that 1/2 and multiply it by 1/4. So I'm going to get 1 over 8 pi, and that is going to be f of x minus g of x squared. And that's what we're going to use to find area. So again, going from area to volume, well, that's just the integral. So my volume is going to be, of course, I'm going to take that pi over 8 out because that's just a constant multiple. So pi over 8. And I'm going to go from A to B, whatever those intersection points might be. And then I'm going to have f of x minus g of x squared dx. And so that's how we're going to find volume for all these different shapes. In our next video, we're going to go over an example of a free response question where you're going to have to answer these different questions where you're finding, like, okay, what if the shape changes from equilateral triangle to an isosceles triangle, or from a square to a semicircle? So how is that going to affect the volume of the shape? Of course, if you need help understanding how we derived any of these formulas, maybe refreshing any of these geometry concepts, please reach out to me. I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.